Hello and welcome. Today we are going to take a look at some applications of similar triangles, and to do this I've chosen this very simple and I hope fun exercise to work on together. So here we go. At a certain time of the day, the shadow of a boy who is 5 feet tall is 8 feet tall. So here's a boy, 5 feet, his shadow is 8 feet long. The shadow of the tree at the same time is 28 feet long, and we want to find out how tall the tree is. So it's an interesting and simple way of measuring the heights of tall trees, I would say. So you can do this activity for fun if you're ever bored at home. So here we go. We are going to answer or solve this problem. Um, what we are going to point at in this case is the fact that, number one, this must be a right angle right here at 90 degrees because we expect the trees to stand upright, perpendicular to the ground level. And we're going to pretend that this boy here is represented by a straight line segment. And I'm going to draw that line segment right here. And now I am going to rediscuss the measurements that I am given here. So I know that I need to find the length from here to here. So that's unknown. And I also know that the ground, which is from here to here, that's 28 feet. Okay. And I also know that the length from this point here, the shadow, right? So that's 8 feet. And we know that the boy here is 5 feet. So as you can see, we have created here two triangles. So this is the bigger triangle and this is the smaller triangle. We're going to say that these two triangles are similar. And in order to explain these things better, we are going to give the angles in the triangle names. So A, B, and C. And I'm going to call this one point D and this one here point E. So we're going to say that the triangle ABC is similar to triangle. Now I have to be careful. So remember that angle A must equal angle D. So that means that the next triangle should start with letter D. And then the next thing is that angles B and E are both 90 because both the boy and the tree are standing at 90 degrees to the ground. I don't know what's going on here. Okay, that doesn't want to work. So we are going to say that we have to continue writing the name of the next triangle with letter E. And then last but not least is C. As you can see in here, actually the angle C right here is a common angle for both triangles. So there is no way of not being, equal. And this is 90 degrees. Then we're going to say these two angles are equal as well. Okay? And the reason why they are equal is simple actually. If two angles in a triangle, right, are equal to the respective two angles in another triangle, then the third must equal because all the angles must add up to 180. So this is 90, this is common, so this must be 180 minus 90 minus the common angle, and so is this angle here. Okay, so getting our hands to work in here, and we're going to write the ratios. So we're going to work with the numbers, and to write the ratios I have to follow the order. So I'll write here AB over DE equals, the next ratio I'll write is BC and EC. And last but not least, I will use the last two letters in each triangle, and we'll say that AC must equal DC. And now I will substitute all the measurements that I know. So AB, I don't know AB. Remember, AB is the height of the trees right here. So we leave it as AB. Now, for DE, we are given that DE is this side, represents the height of the boy, so that is 5. So we'll write that down. Equals the length of BC is from here to here, so that's this green line, so that's 28. And divided by EC, and EC is the length of the shadow of the boy, so that's 8 feet. And I think we have enough information actually. We don't have the lengths of AC and DC, but we wrote the ratios because we wanted to write them all and to consider them all and see what we have and what we need to find. And we remember that you should always use, like in an equation that has 3 sides, you have to use the ratio that has the unknown and one ratio where we know both numbers. Here you don't, so you don't even need to use this. So now all we have to do is solve for AB, and if I let AB be x, sometimes, or even better, I'm going to let AB equal h. Sometimes it's more visual and people find it easier when they use a single variable rather than 2 letters to represent the unknown, like AB. So over 8 equals 28 over 8. Since I'm here, I will reduce this. That would be reduced by 2. So 28 divided by 2, 14. 8 divided by 2, 4. And now we'll cross multiply to solve. That's what cross multiplication looks like, right? I'm going to use this actually because, okay. And then we're going to say that 4h must equal 5 times 14. And 4h equals 70, I'm sorry. And h equals 70 divided by 4, which is equal to 17.5. So we're going to say that the height of the tree is 17.5 feet. That's quite a hole. Okay, so this is the problem that I wanted to discuss with you in terms of applications of similar triangles. I hope this made sense, and I hope you understood everything. And I would just, when it comes to applications, I would just emphasize the fact that you need to draw the diagram. It's very important. It is very important to also indicate what variables you're given or what lengths you're given, what measurements. And whenever we are writing an equation, we have to explain why this equation is true, right? So that's because the two triangles were similar. All right, so hope that made sense, and bye for now. See you again.